Welcome to Stuff You Should Know from HowStuffWorks.com.
Hey, and welcome to the podcast. I'm Josh Clark, and there's Charles W. Chuck Bryant, and there's Jerry over there. So this is Stuff You Should Know about colorblindness.
That's right. Which I didn't know a lot about.
No, I guess I didn't either. It's one of those things you just kind of assume you do, but there's a lot more to it than you realize, right?
Yeah, I kind of wondered about myself, though, because Emily is always telling me that I'm getting colors wrong. Mm-hmm. So I took an online test.
I did too. How'd you fare?
Normal color.
Did you? I took one of those, what's it called? The scope one? Anomalous scope?
Yeah.
I took one of those online, and it said I had just very weak color blindness, which I wasn't very surprised by because dark colors are kind of hard for me to differentiate sometimes.
They said that you don't see black or white. You're like Michael Jackson.
Right. That's right, man. I've always said that, but no one ever listened until now, until I proved it on the internet.
Yeah, thank God for the internet.
So you want to talk a little history? Because believe it or not, there is color blindness history. And I should say also, Chuck, I looked up the more politically correct term for color blindness, and there really isn't one.
Oh, yeah?
Mm-hmm.
Well, that's great.
Yeah. So you can feel free to use colorblind in good conscience, okay?
Fantastic.
So back in 1794, John Dalton, who came up with atomic theory, he was a pretty important early scientist. He presented his first scientific paper, and it was on color blindness. Did you know that?
No, I never heard of the guy.
Yeah, so it was, from what anybody can tell, the first scientific paper on color blindness, and he wrote it about himself. He and his brother were both colorblind, and he posited that he had some sort of blue fluid in his eye that was affecting his color vision, and he willed that when he died, his eye be dissected. And when they did, they found that, no, it was pretty normal. There was no blue fluid in there. And later on, they preserved his eye tissue, and in 1995, he was diagnosed with something called deuteranopia. So he was a deuteran in the parlance of people who are colorblind.
Yeah. Meaning
that he lacked functioning green cones or medium wave cones in his eye.
Interesting.
Mm-hmm.
So he was the first dude, huh?
He was the first one to write a scientific paper on it, at least.
Oh, well, good for him.
Yeah.
And bad for him.
Well, yeah. I think so, too. I don't want to, overstate how bad I feel for people who have color blindness, because I know they're, living life and enjoying it and everything. But
sure.
I would not want to be colorblind if I had my druthers, you know?
No.
And I'm sure most people who are colorblind would feel the same way.
John Fuller used to work with us. I believe he has some sort of color blindness, or maybe calling it color vision deficiency.
I saw that.
Is a better term, because colorblind, a lot of people that don't know anything about it might think, well, if you're colorblind, then you see in black and white.
Which is a form of color blindness, but that's the most extreme form. There's definitely a gradient, appropriately enough, between full color vision, which is called trichromacy, and complete color blindness.
Yeah, so let's get into the vision a little bit.
Okay.
Have we done one on the eye?
Dude, I was like, a lot of this sounds kind of familiar, and I looked high and low and could not find anything on vision, on seeing, on the eye, nothing.
Huh.
So I don't know if we did maybe a video on this once or something, but
maybe.
But some of it seemed familiar, but I couldn't find an episode on it.
All right, so we have a retina in our eye, like everyone knows. The retina senses light, deals with color and vision, and there are rods and cones. They're called rods and cones because of their shape. They look like cones or rods. Mm-hmm. So rods help you see in low light, and the cones are where the detail and the color come from. So the cone malfunctioning or not being there at all, if you don't have three cones, and you have to have at least two to see in any color. Mm-hmm. But if one of those cones of the three if you do have 3, is malfunctioning,
Right.
then you will fall somewhere on the scale of color vision deficiency.
Right. So there's like something called, so like I said, if you have normal color vision, you have trichromacy. If you have anomalous trichromacy, it means that one of those cones is not functioning properly. Although they all still work, it's just out of alignment a little bit.
Yeah.
And the way that it can get out of alignment is those cones, each of them has a chromophore, I think is what it's called, which is like a little molecule that is attuned to a certain type of a certain wavelength of the visible spectrum. And those wavelengths that it picks up kind of overlap depending on the cone. Like red and green cones, what they pick up on the visible spectrum overlap big time. Green and blue kind of overlap, and then red and blue overlap the least. But if the alignment of the wavelength to the visible spectrum within that cone is just a little bit off, you're not going to see colors like other people see colors, but you're still going to see something, right? And that's called anomalous trichromacy.
Yeah, and there are, there are so many different subcategories, I guess. We should go through some of these.
For sure.
If you have that anomalous trichromacy, some of the stuff is so hard, you do have your cones. So that means you have 3 cones, but one of those cones is defective. So if you have the Deuteronomy,
this can be a fun episode.
Deuteronomy. No, wait, that's a Bible book.
Right.
What is it? Deuteronomy? That's right. It just sounds weird.
Yeah, I think so.
I'm really bad with homilies.
I think you just nailed it, man.
Yeah, but it was clumsy, but that's fine.
Deuteranomaly. Yeah, deuteranomaly.
It's a really tough word.
It's an anomaly of your deuters.
That's right.
So that deuteranomaly you're just talking about, that's if your green cones are out of alignment.
All right.
Then there's protoanomaly or protanomaly, and that's your red cones being out of alignment. And then tritanomaly is blue.
All right, so if you're missing a cone altogether, that's for malfunctioning. You have 3, but one of them doesn't work quite right. If you're missing one altogether, you have dichromatic vision. And then we said, of course, the worst is monochromacy. That's basically seeing in black and white and sort of shades of gray.
Right.
But if you are a dichromat or a person with dichromatic vision, maybe that's the PC distinction. It's to not call someone a dichromat.
Maybe.
You think?
Maybe. I saw, depending on your condition, there are like abbreviated terms for it. But I saw people being referred to as dichromats all the time, but it really flies in the face of that whole thing of describing people by their condition rather than like a person with dichromacy. You know what I mean?
Gotcha.
Yeah.
Well, within the dichromat, though, there are the 3 different subtypes, which are the deuter, the proto, and the trita. That's the easiest way to say it.
Right.
So that's what those fall under.
Yeah. And so the big difference between anomalous trichromacy and dichromacy says it all. It means you have 2 functioning cones. And because of all that overlap, Chuck, with all of the wavelengths that the different pigments in your cones catch, that's a huge palette of colors that are produced in the human brain when we look around. But if you remove one of those cones, there's an enormous reduction in colors. Supposedly, each cone multiplies the number of colors by 100. So if you start out with just one cone, let's say you can see 100 shades, just by adding a second cone, you can now see 10,000 different colors. And by adding a third cone, you can now see 1,000,000 different colors, right? So if you remove one of those cones, you're suddenly down to 10,000 colors. That's a significant difference. And that's the thing about dichromacy is it's not that your cones are misaligned. One of your cones just is not producing at all. And so you're lacking a whole range of colors that other people with all 3 functioning cones can see.
Right. And like I said earlier, with monochromacy, that's when you see basically in black and white and gray. And there are 2 types there, rod monochromacy and cone type. And if you have the rod type, you also have very poor vision, and you're very sensitive to light. And you might also have something called nystagmus, which that is when you have, they call it dancing eyes. That's when there's a horizontal version, which means your eye basically darts back and forth to the left and to the right constantly.
Like Pruitt Taylor Vince.
Does he have that?
Mm-hmm.
I've never noticed.
You'd recognize him, and he's just well known for, he's the actor with.
Oh, I know him. I just never noticed his eye.
Oh,
twitching.
Really?
Yeah.
Yeah. You can tell a director's like, all right, let's really get that going for this scene, okay?
Oh, wow. So when you think about the color wheel, red, orange, yellow, blue, indigo, green, violet. I said them out of order. I don't know what that would spell. It doesn't spell Roy G. Biv, though. But if you're colorblind, like everyone wants to know, like, what does it look like if you're colorblind? And it's a little hard to describe because it's very subjective when you think about how each person sees color, because I imagine everyone sees things a little bit differently. But if you're colorblind, that palette is just not as varied. It's more muted.
Yeah, for sure. Because again, those different cones are interacting. They're overlapping to produce a huge palette of colors. It's not like we just see everything in red, green, and blue. There's those things mixed together and interact to produce colors beyond those three. So yeah, if you're missing one, you're missing a lot more than just green or just red or just blue.
Yeah, and things, it doesn't mean it's altogether gone either, because it's on a spectrum, and it depends what kind you have. Like, it could be reddish, but very muted, or green could look a more green-gray, but it's just not that sort of robust standard color wheel that you're used to seeing with what I guess you would consider normal color vision. For
sure. And like if you have one of the opias, if you have like protanopia, which is your red cones don't function at all, the reds are brownish, the purples are bluish, your yellow's totally normal, but the green is also kind of like a weird kind of khaki brown itself. And that really overlaps with deuteranopia too. The big difference between those is that your red, what would look like a dark brown to a protanope, for a deuteranope, it would look kind of like a drab brownish olive, which is not what you want to see when you look at like a bright red apple.
Olive? Look at that huge olive.
Right. It looks delicious, and then you take a bite and you're like, that's no olive.
So let's take a break, have some olives, and we'll talk about animals and testing for color blindness right after this. All right, so I think a lot of people have always heard growing up on the playground that animals see in black and white, especially dogs and cats see in black and white. Some animals see in color, some see in black and white. It kind of depends. Dogs and cats, they actually do see color. They just don't see the whole Roy G. Biv color spectrum that you and I know. Apparently apes and monkeys see the same way we do. Then you have really colorblind animals like black and white types, like raccoons, seals, whales.
Black and white types.
Black and white types.
I love it.
And then birds apparently see more color than we do.
Yeah, and there's other animals that see things like ultraviolet. Like there's a visible spectrum, but that's what we humans see. Where technically, if you had like some sort of chromophore and an opsin that worked together in a cone to produce the red, green, or blue, if you had one that was attuned to gamma rays or X-rays or ultraviolet or infrared, we would be able to see in those too, but we don't have that. Yeah. But other animals are attuned to other things. And yeah, from what I saw too, birds seem to really see colors like nobody's business.
Those birds.
And dogs, I think, tend to see blues and yellows just like us, and a little more robustly. And the other colors on the spectrum are more muted or just don't show up like we see them at all, or more like browns or something like that. So if you get your dog a ball, you want a blue ball or a yellow ball. They'll be able to spot those a lot easier.
Well, It doesn't mean they can't see it. It just means they'll see a grayish ball, right?
Yeah, if you get like yes, for sure. But who wants to play with a gray ball?
Okay.
I think is my point.
I always wonder how they test for that stuff in animals.
You just ask.
Yeah?
Yeah.
Blue. Red.
That's a good Scooby impression.
All right, so testing for this, you can go on the internet, of course, and you took one of the anomaloscope tests.
Mm-hmm.
I took what is known as a PIP, which is a test called the Ishihara plate and pseudo-isochromatic plate.
Mm-hmm.
So this was a doctor in Japan. He developed this test for the Japanese army, Dr. Ishihara. And if you go and look at it, it's really kind of cool, slightly psychedelic looking. It's a circle composed of a bunch of little colored dots. Back in the day, he would just hold up cards, like a Rorschach test.
Like watercolor cards.
Yeah, and it's a circle with a bunch of little colored dots in the middle. And then within all those dots, there is the shape of a number composed of different variations of colors. So there will be like a circle with a bunch of dots that are mainly red and shades of red. And then within that will be like a number 4 that's really, really close. And it depends. Some of them really stand out as obvious, and some of them really blend in and are camouflaged almost. And you pick out these numbers and say what number you're seeing. And then after you go through this whole series, they'll be able to say, like, you're pretty good on the reds, but you obviously have trouble with the greens or something like that.
Yeah, because depending on what color scheme they use, if you are like a protanope and can't see reds, you're not going to be able to pick out the red 3 that's embedded within these dots because you can't see red. It's all just going to fade together and just look like a field of dots to you. Whereas somebody else who can see reds would just see it clear as day that there's a 3 in the middle of that circle.
Yeah.
Which is a pretty ingenious test, and that was like the test for a while, but it's definitely advanced by leaps and bounds since then. There's more tests than just showed up in this article. There's one, I can't remember the name of it, but it's made of, you have 4 rows of something like 20 or 30 tiles of varying shades across the spectrum, and you're supposed to basically put them in order to match a line, like a control line. And it's kind of like an anomaloscope test, but it's more hands-on.
Yeah.
And then there's one that I think the Coast Guard and the Navy and the Air Force use called the Farnsworth Lantern test. Farnsworth Lantern test.
Yeah, my brother-in-law's a Marine, and he's a pilot, and he had to take this. So this is an additional test, basically. Mm-hmm. If you fail the PIP test, then you will use this. The FAA also uses it because if you want to be a pilot, you can't be colorblind. So it's basically a backup, and it's like a little box that shows you colored lights. And you have to identify these colored lights as they come up from a distance. They'll show 2 at a time, maybe 1 at a time, and you just have to pick them out and identify the colors. But they do dim. They use a filter, so like you can't cheat your way through by knowing that something is bright, so it might be yellow.
Right, because if when you start looking at colored lights and stuff like that, it does become clear that some are just brighter than others, which is why I think people who have yellow-blue colorblindness or tritonopes, they tend to be very sensitive to bright light. Which kind of makes sense in a weird way, but a lot of this stuff, I was like, wait, how does that happen again? Like deuteranopia and protanopia, they overlap so much that they call both of them red-green colorblindness.
Yeah.
And they both see reds as browns, and they see greens as browns. But it's just bizarre to me. And when I really kind of drill into it, the actual details of it are really fascinating because you just are raised your whole life to think like, oh, this person can't see red, this person can't see green, or this person can't see blue. And it's as simple as that. And it's the exact opposite of as simple as that in reality. Because there's so much nuance to colors that are produced by these 3 RGB cones.
Yeah, and I mean, imagine diagnosing a kid. I mean, it's not, we'll talk a little bit about living with colorblindness in a bit, but it's and I'd love to hear from people. It's not like it might hamper you, I don't think, to the point of danger, I guess maybe if you were a monochromat, that might be possible.
Sure.
But it seems like more an inconvenience than anything else, right?
Yeah, you'd be like, what is this black liquid pouring out from a major artery in my arm? I don't know what this is. If it were red, I would know it's blood.
That's right.
Yeah.
As far as how it's caused, it is largely genetic, although there are some drugs and diseases and conditions that could cause it later in life, but it's generally genetic.
Yes. So, especially red-green colorblindness is, sex-linked recessive.
Yeah, and way more men and way more Caucasian men get it than women.
And I'm not quite sure about the Caucasian part. I couldn't find any explanation for that, but there's a very clear and easy explanation for why more men have it. Something like 8% of Caucasian men and I think like 5% of Asian men tend to have red-green color blindness of some varying degree, right? And if you have red-green color blindness, 50% of people are going to have mild, and the other 50% are going to have it so severe that it would basically be protanopia or deuteranopia, which again means your cones just aren't functioning like one of your cones isn't. But the reason why there's way more men than women, I think something like 0.5% of the population in the U.S. of women have color blindness, is because it's carried on the X chromosome.
That's right.
And since it's recessive, men only have one X chromosome and they have a Y chromosome, which means that all of their color vision genes are just on that X chromosome. And since it's recessive, if that one gene is defective and that you don't have normal color vision, the man's going to have color blindness. But for a woman, it takes two defective X chromosome genes, right?
That's right.
So that makes it sex-linked recessive, which is it could be an okay album name. I don't know about a band name.
Sex-linked recessive? Sure.
Yeah.
And I talked about diseases and conditions. Glaucoma is one, diabetes, Alzheimer's, Parkinson's, leukemia, MS, sickle cell, alcoholism. If you literally drink yourself colorblind, like that sounds like something made up.
Yeah, it does.
You know?
You wouldn't be able to detect the pink elephant anymore.
Yeah, that's true. You say, who's that gray elephant? And they say, all elephants are gray.
Drinking yourself colorblind, man, that's nuts.
That's a Tom Waits song.
There's also, it should be for sure. There's also like some drugs that can do it too, right?
Yeah, I didn't get to look into these as much though, but it says that digitalis and chloroquine.
Yeah, the second one's a malaria treatment, and the first one is a reckless heart treatment.
Yeah.
But I guess both of them can cause color blindness. The thing about color blindness, if it's acquired, if it's genetic, it's probably red-green. You're probably a boy, and you're probably a Caucasian boy. That's the likeliness. But if it's acquired, it's likelier that you're yellow-blue colorblind, right?
Yeah.
And that can actually get better if it's acquired. It can get worse, but it can also go away depending on, say, if you stop using the drug that is causing color blindness, or maybe you give up drinking.
Right, but there's no cure for color blindness genetically, so you can't take a pill or get a shot or get any kind of treatment. There apparently are corrective lenses that they have out there, but I don't know about that. That doesn't sound like a great idea. I'm not sure how effective those are.
Supposedly they like kind of work for color, but they also affect like depth perception too, which it's kind of robbing Peter to pay Paul in that sense. Maybe even worse than that. Interesting. And I looked them up. They don't seem to be any further along than when this article was written. But there's gene therapy. It just hasn't been tested in humans, but it's been shown to work in monkeys, where they inject genetic material directly into the eye and hope for the best. But apparently it works in monkeys. Again, same thing as what you were saying. How do you know? How do you test for color blindness in animals? I want to know. It's fascinating, just the idea of it.
I bet someone out there knows.
Sure. Hopefully they'll write in. So let's take a break, and then we'll come back and talk about living with color blindness. Chuck, how about that?
Yeah. All right. So like I said before, and I do want to hear from people that are colorblind. It seems like more of an inconvenience than an actual danger or a threat. Mm-hmm. It could limit like maybe what kind of job you might want to get. Like I said, you can't be colorblind if you're a pilot or if you want to be a pilot. It's funny, they mentioned in here, if you're an electrician, like color-coded wires are a problem.
Right. Yeah.
Never really thought about that, but that's probably a pretty good point. Or I guess if you may never work for a bomb squad.
Oh, yeah, that's a good one.
That's your life calling. That's sad.
I also saw if you're a meat inspector, you probably can't be colorblind.
Oh, sure. Looks good to me.
Right. It's all gray. Instead, it's all good.
Oh, God, gray meat.
And similarly, if you have a red color blindness, you can't tell whether a steak's cooked or not based on color.
Ooh.
And similarly, if you have a green color blindness, you might have trouble with ripe fruit, whether fruit's ripe or not.
Luckily, anyone that knows what they're doing with a steak, you could be blindfolded and cook a steak right.
Sure. And plus, even if you don't know what you're doing, there's meat thermometers that all you have to do is get it to like 160, I think, and you're all right.
Yeah, but I mean, we've talked enough about cooking steak in here.
Sure.
It's a time thing, a temperature thing, and at the very least, you can touch it and know what's going on.
Sure. If it gives your thumb frostbite, probably not done yet.
Because if you're cooking a steak by color, that means you're cutting into the steak to see if it's done.
Right.
Which is the worst thing you could ever do.
It's a sin.
Yeah. I'm horrified at that whole notion.
I am too, Chuck.
What about little kids getting dressed and coloring crayons? That's why crayons are labeled.
Right. But I mean, if they use some names that don't really mean anything to the color, that's not very helpful, But
sure.
Yeah, if you have crayons with the labels peeled off and you're colorblind, that's not good. I also saw diamond appraisers.
Oh, interesting.
Casino dealers because of the chip colors. But now they have things like software that can actually change colors on the web so that you can see them more clearly depending on what kind of color blindness you have.
Oh, interesting.
So I think it used to be like a real problem, and then they came up with a lot of different software that you can buy and just run on your computer, which that's got to help quite a bit.
Yeah, that doesn't surprise me. I mean, I figured in the olden days it was just like, well, sorry for you, but now there are so many different things that they can do to help people out with various like slight conditions like this.
For sure. And I think a lot of the worries were kind of overblown. Like the FAA used to say like you have to have normal color vision to be an FAA employee. And they repealed that in 1996 because there's so many other ways you can design things other than colors.
Right.
And it's still a problem for what I can tell. Like with color blindness, the same light will be used on like an electronic thing to show it's fully charged or to show it needs charging. Whereas if you just have a light blink to show that it needs charging, that would help tremendously rather than just using a green for fully charged and red for needing charging. That doesn't help somebody with color blindness because it just looks like an ugly brown light to them.
Yeah, I never thought about that. A lot of things blink now, though, that I've seen.
Right. And I'll bet that's why, actually, because it's just a better design.
Yeah.
Not using different colored chalk for emphasis in school. Using for graphs rather than like just colors. You can also use like cross hatching or dots or something like that to indicate differences. And then the reason I said why it seems like people are coming around to the idea of it being unsafe to be colorblind in this world, being overblown. Japan had a real bias against people with color blindness for many, many years. Did you read that article I sent?
I didn't see that one.
Man, so back in, I think, 1920, the Crown Prince Hirohito was about to marry a woman, and it turned out that she had color blindness in her family. And one of the royal family stepped up and was like, I don't want him marrying this girl because her family has color blindness in her lineage. And the marriage went on anyway, but the publicity involved really got people's attention, and they really took it to heart. And for decades, up until a few years ago, there was discrimination against people who were colorblind. Like, you could not enroll in some high school courses or college courses if you were tested as colorblind, and all kids were tested at a young age to see whether they were colorblind or not. You couldn't get some jobs, and not even where it was conceivably safe or unsafe. It was just like discrimination against people who were colorblind. In some cases, people who were fully blind could enroll in some courses that people who were colorblind could not. So there was like no scientific basis to it whatsoever. It was strictly like this kind of distaste for colorblindness that had been in the culture since 1920. It's finally fading away as time goes on. They stopped testing kids in Japan in the last year or two for colorblindness because they're like, we understand it better now, and you're not a monster for being colorblind anymore.
Man, that's amazing.
Isn't that interesting?
Yeah.
Yeah.
There's something you should know.
Yeah.
Something I should know.
So colorblindness, Chuck, you got anything else?
No. Well, actually, that one little interesting tidbit that apparently people that are colorblind can pick out camouflage better.
Oh, yeah.
Because they look more at texture than the actual color.
Yeah, I saw that they make better spotters for sniper teams.
Nice.
Yeah, I guess so. All right, what about now? You got anything else now?
Nothing else.
So if you want to know more about colorblindness, go ask somebody who's colorblind. I'm sure they are going to have some fascinating stuff for you. And we want to hear from colorblind people too. So please let us know what it's like to live as somebody with a color vision deficiency or colorblindness, or let us know exactly what we should say. And since I said that, it's time for listener mail.
All right, I'm going to call this little Price is Right follow-up.
Okay.
We just released our live game show live in Denver, Colorado, where we had a lot of our Stuff You Should Know Army members traveled in and met each other for the first time.
Yeah, that was pretty cool.
Which is really, really neat. We had a backstage hang, and you know who you are, folks, so it's great to see you as always.
Yeah.
We'll be back to Denver because we did 2 sold-out shows there.
Yeah, it's a great town.
It was really good. All right, so here we go with a little bit about The Price is Right. Hey guys, fairly new listener, started in July. Wow. Well, welcome to the show, David. But he's working his way backwards, which is great. So he listened to game shows, and he said, I'm a child of the 80s, and like Chuck, my summer and home sick from school days were built around a plethora of awesome daily game shows. When talking about The Price is Right, Chuck mentioned trotting out the very tough cliffhanger game. And this might throw me into the dork category, but I'm obsessed with getting on the show. I've been to 3 tapings in the past year, and I've studied tips and tricks. So he's like, what's his face?
Oh, man. I wish.
The guy who beat...
yeah, Michael Larson.
Yeah, Michael Larson. Except he's the Michael Larson of Cliffhanger. He said he claims this is a 100% foolproof way to win. So listen up, everybody. Every time he's done it, it's worked. Here's the trick. For the first item, bid $20.
Okay.
Whatever the actual price is, doesn't matter. Add $11 and make that the bid on the second item.
Okay.
Then whatever the actual price is for that item, add $11 to that. And he said it works every single time.
Weird. I wonder why.
I don't know.
Well, they're probably going to change it because, as everyone knows, Drew Carey listens to Stuff You Should Know religiously.
I'm sure Drew Carey does not care one bit who wins and who loses on Cliffhanger.
I don't know, man. I read this, I think a GQ or Vanity Fair article about this guy who was accused of cheating on The Price is Right, and Drew Carey was mad about the idea.
Well, sure, if you cheat.
I guess that's true. Yeah, that's a big distinction.
And then he says this, my other interesting tidbit is regarding the Japanese game show that you discussed, Takeshi's Castle. Starting in 2003, Spike TV took old episodes and dubbed them in English, and it totally transformed it to one of the funniest things you'd ever watch. If you have 20 minutes to burn, hop on the YouTube and catch an episode. Thanks for the great work. That is David Mills. I have a cousin named David Mills, and I'm assuming that is not you.
You never know.
Surely he would have just texted me.
Cousin Dave? He's the formal type.
Yeah.
He doesn't like to take shortcuts.
Hey, man,
except
I like
with
it.
Cliffhanger.
Yeah.
Well, thanks a lot, Cousin Dave. We appreciate that. If you want to get in touch with us to share your tips and secrets for game shows or for getting through life, whatever, we want to hear from you. You can hang out with us on socials by going to our website, stuffyoushouldknow.com, and finding all the links there. Or you can send us a good old-fashioned email. Send it to stuffpodcast@howstuffworks.com.
For more on this and thousands of other topics, visit howstuffworks.com.